Hello students. Now we are continuing objective number 10 for Algebra 1. We're going to be looking at this problem here. Here we are given a table of data that has to do with the cost of a bus ride from the STEM Academy on the Cumberland Avenue route. Now this is just data that I made up. So for example, if we travel 1 mile away from the STEM Academy to 17th Street, the cost of the bus ride would be 75 cents. If we travel 3 miles to Neyland Drive, the cost would be $1.25. And if we travel 4 miles away from the STEM Academy to Cherokee Boulevard, the cost would be $1.50. Now, over here it says that there's a linear relationship between the cost of a bus ride, represented by C, and the distance to the stop, represented by D. We are asked to write an equation that relates the variables C and D. So, first of all, we need to know what our output and input variables are. Okay, so the input is going to be the distance. All right, that's the independent variable. The output is the cost, which is the dependent variable. Okay, so the cost depends on the distance. So our equation is going to look something like this. C equals, and then some function of D. Okay? Now we're told that there's a linear relationship, which means that we're going to fill in this blank. So there's going to be some number that we multiply by D, and then there's going to be some number that we add or subtract from that D. Okay? Just like with the other tables that we looked at in the previous video. So the problem then boils down to figuring out what these two numbers are. What do we multiply by D, and then what do we add or subtract? So let's look at the table. Just like what we did with the tables in the last video, I can show you these real quick. Just like these tables, we're going to figure out how much the independent variable changes by, how much the dependent variable changes by in each row. So let's do that. So from here to here, the distance goes up by 2. Here to here, the distance goes up by 1. From here to here, the cost goes up by 50 cents, so 0.5. Here, the cost goes up by 0.25. Okay, goes up by a quarter. So, the number that's going to multiply the D is going to be how much the cost changes when the distance goes up by 1. So for each mile that we add on to the trip, it looks like the cost goes up by a quarter, 0.25. Okay, so the number multiplying the D is 0.25. Now look at how I found that. Between these two rows, we go from 3 to 4, so distance increases by 1, cost increases by 0.25. Okay, so that's the easiest way to find out what number multiplies the D. Now, if we didn't travel any distance at all, we just hopped on the bus and then hopped back off. Okay, so distance is 0. What would the cost have been? So what is the flat cost of getting on the bus? How much would they charge just to let you on the bus? Even if, you know, the distance, even if you didn't go anywhere. Well, let's try to extend this pattern backwards. So if the distance were 0, what would the cost be? Well, each time the distance goes up by 1, cost goes up by 0.25. So let's make the distance go down by 1, so the cost is going to go down by 0.25. Okay, so 0.75 minus 0.25 is going to be 0.5. Okay, so the bus driver will charge you 50 cents, $0.5, just to get on the bus. Okay, and this relationship represents this pattern. Okay, and it allows you to extend further. So if you traveled more than 4 miles, you could use this formula to figure out what the cost would be. And you can also extend it backwards. So let me just write this out a little bit cleaner. C equals 0.25 times D plus 0.5. Okay, that is the equation that relates these two variables. Now, let's look at problem 10.5. We are told that there's a linear relationship between the number of hexagons, n, in the shape above, and the perimeter, p, of the entire shape, outlined in black. Fill out the table to the right, and then write an equation that relates p and n. Now, we're told that it's a linear relationship, just like up here. That means that the equation is going to look like this. The perimeter equals some function of n. So there's going to be an n in there. There's going to be a number multiplying the n. There's going to be a number added to or subtracted from the n. Okay? And then our goal with writing the equation is going to be figuring out what that number is, what that number is. Now, what's going to help us out is if we analyze this diagram and fill out this table. Okay? So let's look at what we're given. We're told that if there's just one hexagon, the perimeter is 6, right? 1, 2, 3, 4, 5, 6. Okay, that's the perimeter. Now, when there's two hexagons, what is the perimeter? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, the perimeter is, when the number of hexagons is 2, the perimeter jumps up to 10. What about if there's 3 hexagons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so we can fill out the first 3 rows here just by looking at the diagram. But can you kind of see the pattern emerging here? As the number of hexagons increases by 1, the perimeter increases by 4. Okay, so we can use this pattern, plus 1. We can use this pattern to figure out what this next blank is going to be. We're just going to add 4 to what we have up here, so that's going to be 18. So if we were to draw the same exact shape, except with 4 hexagons, the perimeter would be 18. Now, what happens if the number of hexagons is 10? Well, this would jump up by 6. How much would the perimeter jump up by? Well, it's going to be, well, how would you figure that out? Not sure. There's a couple different ways to do it, but let's take what we have so far and write this equation, and then use the equation to figure out what this last blank would be. Okay? So the equation is going to be p equals something times n plus or minus something. Now, the something multiplying the n is going to be how much does the perimeter change by when the number of hexagons, n, increases by 1? Well, n increases by 1, p increases by 4. Okay, so the number multiplying the n is 4. Now, if the number of hexagons, well, don't think of it as the number of hexagons, think of it as n. If n were 0 up here, if n was 0, what would p be? Well, we would go down 1. Same thing here, we would go down 4. Okay, so 6 minus 4 is going to be 2. Okay. That doesn't make sense in the context of the problem, in the sense that you can't have, 0 hexagons having a perimeter still, perimeter being 2. What does that mean? You could think of it kind of like this. It's going to be a straight line, right? And you're going to go down and then back up, right? So that's not a hexagon at all, but you can think of it like that, but really don't worry about the interpretation of what this would mean. This is just a way for us to figure out what this pattern is, okay? So if n was 0, p would be 2, okay? Positive 2, so plus 2. So the perimeter is equal to 4 times n plus 2. Now let's use this equation to figure out what p would be if n is 10. Well, just plug in 10 for n right here. 4 times 10 is 40, plus 2 is 42. Okay, so we can predict that the perimeter of a shape like this would be 42. if the number of hexagons was 10.